Good morning, it's me again. This is gonna be my very last presentation. I said the objective of these videos, putting them online, is basically because I wanted to prepare for job interviews, and I did. It helped. I have a job now, so that's why it's gonna be my last presentation in this series. The series was about it's really ICT management for managers, not technology managers, but business managers. Just to introduce myself, I'm doing well. I'm an independent consultant, but now I'm working for a smaller consultancy company with a very big client on a very exciting project. Um, I think what the question I often get is, oh, but you're not a Microsoft engineer, or you're not an Oracle engineer, or you didn't get certified in the ServiceNow platform. I don't think that's necessary. Although my intention is to get some more certifications. My basic certifications are uh, I have a certified agile practitioner certificate from the Project Management Institute, and an ETL version 4 certification. And then I have certifications in, well, almost all languages, back end, front end. And so I want to present these things because they relate to questions I get on, oh, what do you think about this architecture? Or, what are we going to use for this? And so I want to talk a little bit about that, not to, again, to give the impression I'm a technologist. I am, but that I'm not. I'm not a geek. I'm not an expert in many specialized areas of expertise. But yeah, nowadays you cannot do a business project without sort of knowing, yeah, how stacks work, how these moving parts in an application, these moving components, evolving technology stacks, what they're all about. So I'm gonna give a bit of a subjective, very subjective appreciation of what I've seen happening over the last 20, 30 years, when you're in this business. And I'll start with this. This is an incredibly complicated and chaotic page in my notebook, but I'll walk very slowly through it. It is the TIOBE index. You may or may not have heard about that. TIOBE stands for the importance of being honest, apparently, but it's the name of a Dutch software company that tracks technology development and preferences of for languages, for certain technologies, and I think they do an excellent job with that. This one is on their, I would say, sort of popularity index of programming languages. And the interesting thing about this is that it's objective. I should look into their methodology, but the interesting thing is they base it on what they call the concept of um, skilled engineers, skilled engineers that are there, and or demand for people who want to do, yeah, certain certifications. So they scrape websites and all that, and based on that, they arrive at an index for each of these things. So let's get going at it. It gives a very nice evolution from 2000 from 2000, and then now we are almost 25 years later. The big shifts you see is that Java. Java. I'm an old man. I started in the business with COBOL and Case Tools, the very early low-code platforms, computer-aided software engineering. So I started in the 1990s, and you saw this huge climb of Java, Oracle becoming very popular and making a lot of money, and still making a lot of money, and challenging Microsoft and and Google, and they still do. And so they were above 25%, and clearly the leader when it came to what I would call backend programming languages. The other, and that's where the comparison needs to be made. The other backend languages now are no longer COBOL, of course. The C family, still the classical C, C++, the enhanced version, and then C Sharp, the object-oriented version of COBOL that wanted to take on Java probably a little bit. And then there's Python. I really love Python. I said I did my certification. I enjoyed my Python certification very, very, very much, especially because it tied in with data science, the use of Python. I have an interest in math, so Python is lovely and is for me, yeah, it's going to continue to be a winner. It came from 0 to now 15%. Let me clean up my notebook. The other, as I said, they're not legacy, they're the future. The C, C++, C Sharp, 35%, 30%. They're going a bit down, but that's very steady. And Java is now under 10% in terms of what people want to learn, what the skills are on the market. If you're a Java developer, you know that the market is very good for you. But I put a very sharp, blunt question here, which I will answer just to make sure that I get your attention. Could Java be the COBOL of the future? In which I mean that it's losing popularity. People do find it difficult. So is it kind of a legacy language? It's not, obviously. I'm exaggerating, but it's a question worth thinking of. COBOL made the transition to C. I'm going to talk about that a little bit. With Java, we see a huge demand or huge interest in, how does Java integrate with Python? And then languages like Go, Golang, they really have interesting integrations that increases the ecosystem, I would say, around them. Java does the same, but it runs on a different platform. The Java runtime environment, Jakarta Enterprise Edition or EE. It runs. It's a different beast. And when we talk about stacks, what are stacks? You think about .NET, Windows, of course, but indeed then Oracle, JVM. We have stacks that are really front-end stacks, JavaScript, PHP with frameworks that come with it, Node.js and Angular. We have Mean now. Mean means an in-memory database, and an Angular and Node.js. We have Docker, Kubernetes, very interesting. I learned as much as I could about it this year. But I would say the stacks here would all be compatible or easily integrated, except for that's still that Oracle, the Java virtual machine runtime environment. And I think that's a bit the reason why, slowly Java is no longer the darling of people like me. Let me refocus a little bit. So we have this market share. I would say, indeed, Java is now 20%. I would say of the backend, and the other, which I actually, you kind of run these things in Linux and Windows, in containers. Windows containers or Linux containers on OS X at whatever. Java, it has that special virtualization layer, I would say. Its market share is going away. I think it's there because Oracle is there, right? And Oracle database might also be maybe not, probably not. Surely not when I speak to people. It's all about, oh, well, do you know Oracle? Do you know Java? I usually reply yes, but not well enough because yeah, I'm not a fan, as they would say. Um, so that's the bit 80/20, and that's interesting about this index. Um, that doesn't quite reflect sort of the buzz with managers. Although at the same time, one reason I did this is about 3 months ago I was in a workshop. There was a public sector CIO, Chief Information Officer, not the one I worked for. But he was very interesting. He was talking about his experience in implementing the new low-code platforms, Mendix basically, but you have OutSystems. Mendix has the advantage that its engine runs on this Docker, Kubernetes, and he was the one of the first one, and I found it very refreshing. Who showed on the screen like, this is what Java looks like, and this is how long it takes sort of for them to come up with something, a new application. And this is the low-code platform where I had to smile because it is very familiar and intuitive. You have your data model, you have a function or a process model, and then you design the interface using forms. Everybody understands forms and GUI forms, and bang, off you go. It works, it runs. And apparently, but that's something I haven't checked. These new low-code platforms don't suffer from, what killed them off. I think 30 years ago is, a lot of overhead, quite difficult in terms of, cross-platform implementation because you need all these engines for different platforms. So 30 years ago, low-code was great when your architecture was a classical monolithic mainframe architecture, but we all know that architecture is it's not completely gone, but it's pretty much gone. Again, coming back to the to this graph. So I said I would sort of say this graph. Let's decompose it and distinguish between the backend and the front end. On the front end, you have JavaScript, PHP. JavaScript is a server-side scripting language, PHP. They work well together. They have nothing to do with Java. They're also losing a bit of a market share, which I find surprising. It's 5%, but it's 5% within. We're comparing apples and oranges here. What I read on other websites to corroborate it is that 75% of all web applications use PHP and JavaScript. You usually often use a bit of both or PHP only. But so that 5% market share doesn't reflect the reality is that 75% of your web applications, the engine behind is PHP and JavaScript. So so I'm a bit surprised. It's probably because these are relative market shares or relative indexes. So I think in absolute numbers, JavaScript, PHP are clearly there. What is the other 25%? Java server pages, I guess, and then Visual Basic, the old .NET with the cloud components. That also went down, to my surprise, a little bit with IIS. But again, that's not what I see, what I hear. I think these numbers came down, not like from 25 to less than 10%, a reduction by a factor 3. Here we're talking about halving. I think it's because of all the newcomers. The newcomers are Go, which is not reflected in the graph, but is ranked number 11 now and climbing fast. And I really like it. Go has good integrations with other languages, with C and C++. What I like about it most is that it combines, when you read about classifications of programming language, you're going to hear about, this is a high level, this is a low level language. I think and here I quickly gonna, because this slide is indeed very confusing, I guess, but I have more confusing things. This is technical detail. Computer is a bit slow. Problem with these whiteboards, once they go over 20 pages, they become rather huge. Puppet service. Maybe I don't have it. What I wanted to show is, yeah, how a language like, yeah, we can talk about how they use arrays, how they use, how to what extent they are object oriented. Stick with me. Yeah, this is what I wanted to show. I think a good programming language should enable you to do really both high level coding. Think indeed of sort of object oriented here, but also low level management of resources, and being able to sort of see how exactly something runs behind. So here's the example of C++, which I like very much. We what we do is we include a few libraries. I love the concept of namespaces, a logical grouping of all. Your applications are a lot of files, so and a lot of functions and variables, a lot of names. You organize them in a namespace, and that provides logical grouping. I like that a lot more than how Java does it. And then you have, your main package, I would say. We define a string here, and this is kind of nice. I just print here, and I use that. This is a pointer, and it tells me where the memory address is, where this this string, this variable is going to be stored. You will say I'm getting into the weeds, but I like that. And C++ has that. Google has even more than that. It's really excellent for concurrent programming. You'll all have heard about how important it is to do in an asynchronous client-server environment, so no simple HTTP request responses, no real-time stuff that you need to do message queuing and keep track of stuff like that. Go does that very well. Keeping track of indeed concurrent routines that are working and waiting for results from the other while doing really parallel processing. Let's go back to the TOB index. I made way too many notes. But yeah, now that I'm here, I think there's way too much emphasis on, it should be object oriented. So we introduced object orientation over the last 23 years. I mean, it was introduced by the industry. For me, it's not the big revolution in terms of making coding easier. I grew up with entity relationship diagrams. You have entities and then the instances, and an entity gets instantiated by an instance, which translates into a record, which has some fields. So we were struggling then with things like, okay, how do we have like a recursive relationship, employees manage other employees, how do we do that really in the database? At the time, self joins, of course, they were there. That's a story I can't tell. I worked together with a really good database specialist. Said, well, self join will create like not one table but two. I think that problem got solved. There's no performance issues anymore. The other thing that was far more intriguing at the time was a subtyping. So we have a vehicle, and that vehicle is going to be a four-wheel drive or a two-wheel drive. So we have subtypes, and now we know that if we go to object, we can define methods, but let's stick to the attributes or the properties now. We will have slightly different or more attributes for a four-wheel drive. than for a two-wheel drive, or vice versa. So the topic of inheritance and subclasses was always there. How do you deal with that? Do we define attributes here at this level or at that level? Well, the attributes that these two have in common, of course, should be defined here, and these should only have the specific attributes that we have for a four-wheel drive or a two-wheel drive. All right? Yeah, no, of course. Well, it's right, but things were complicated 30 years ago because we also thought like, when you start thinking about these things, you need to ask other questions as well. Do we have exclusive subtypes or non-exclusive? Clearly, these are exclusive. A two-wheel drive is not a four-wheel drive vehicle. But the other question is this classification complete? Are there any other types of vehicles than two-wheel drives or four-wheel drives? And I'll give an example here. We have the all-wheel drive. The all-wheel drive is, it drives on all four wheels, but it's not a four-wheel drive. Four-wheel drive provides traction to the two wheels in the front and two wheels in the back. An all-wheel drive will sort of dynamically shift power to all four wheels in a different way and optimize it for the road conditions. So is an all-wheel drive then a four-wheel drive? Probably not. Another question would be, maybe in the future, can a vehicle exist without being a two-wheel drive or four-wheel drive? So we did combine what we call that IDEF and the methodology I still love, information engineering, in our data model, by inventing a symbol. Well, not inventing, this is the symbol. So we have complete and incomplete subtyping classifications. They can be exclusive or not, and then we had the symbol. The whole issue then was, again, and that's where, as a programmer, you cannot say, "Oh, that's for the operations department. That's for the database engineer." Well, no, you need to talk to him because the physical database will not directly support inheritance, and that's still the case for relational database management systems. And I would say for others as well. There are always various options. I'm quoting here from Stack Overflow, a nice interview, a nice Q&A. I said, like, okay, we can do only one table, okay, and then the child fields that we have for four-wheel drives, and we're gonna implement these as nullable child fields, but we have one huge table. The other option is that we have no parent table, only child tables, and we just repeat the attributes here at the vehicle level. We repeat them at the level of the subtype. So you have only tables at that level. A logical data model is implemented in our database like this, and this. We forget about it when we move from the logical data model to the physical data model, our data definition language. Okay, that has pros and cons. Separate tables for a vehicle, and then separate tables for our subtypes. And then we split those fields over these three tables. Each option has pro and cons, and they relate to a very important factor is, what if our database schema, our logical data model, is going to change? I said we add another type of vehicle like an all-wheel drive. How much time is it going to take us? And what do we need to do, and what are the implications for all the code that is built on top of our database to make that change happen? So the ease of change of it's not easy to change a database and regenerate everything, an image of your database loosely or tightly coupled with other service components in your architecture. So you have that issue of maintainability. This query performance, I think, because of the huge increase in performance of all technologies we work with, that's less of an issue. But another one is the enforcement of constraints or business rules. like the way stored procedures would work on a database. But all these, it's got to do with the integrity of your transactions. Yeah, these considerations are there, and in the end, of course, you always find a good solution when talking. But I'm just want to highlight this, that object oriented is not like a magical bullet. These issues have been there forever, and they will be there forever. And it's not by launching some kind of new philosophical scheme that you're gonna solve it. Let me go back to my TOB index. Mhm. Yeah, I think I'm done with it. Yeah, maybe just very soon. You may say, oh, these percentages, 5%. Go. I would say this is the other problem with this index. It really mixes apples, oranges, pears, and a few other animals, because it also keeps track of good old classical SQL implementations. Fortran is still there and actually gaining popularity. Delphi, object-oriented Pascal, and it also has R and MATLAB and a number of other ones. An interesting one I found is Scratch. Scratch is a coding environment for children. I hadn't heard of it before, but apparently very, very, very popular. Easy to work with. But so yeah, for young children. Interesting. I guess it's got to do also with AI coming up very quickly. I'm joking, and then I'm not. Yeah, my personal example again is my own programming skills go back to using COBOL and BASIC in various variations, and then yeah, low code with the good old information engineering facility that became Composer. So I redid my certifications, and I'm certified in about 60% of what you see here, and that's where I think again it's subjective appreciation, but where I can safely say, like, some things feel better than others. Um, Yeah, I wanted to talk about again the specificity of Java. Java is really the odd beast out. It's associated with a very, very specific stack or ecosystem. Java, Jakarta EE, Java server pages on and Java servlets for serving HTML pages. The development environment will typically be, very specific. Eclipse is there. Your web server will typically be, Apache Tomcat, and Apache Tomcat is not the same as Apache HTTP server, which will run again on Windows OS X, but it's not associated with the Java runtime environment. It's not associated with the Java server, JSP, Java Expression Language, WebSocket technologies. So if you see Coyote, then you're in this stack. Of people say, oh, Ajax. Ajax is not Java. It's asynchronous JavaScript. The S is not there, but it's JavaScript and XML. So yeah, a very specific stack. And my question still is, we're 2024, is really when you talk legacy, future developments, it's a little bit Oracle and is Java stack against all the rest, which I symbolized by this thing here. Sort of being very bold. Something I found very interesting about how the software industry dealt with COBOL legacy systems. There were two ways of dealing it. You either still work in that environment, which you can do. IBM supports COBOL. COBOL has new versions, object-oriented versions, apparently, and so you can use a native compiler and still run stuff the old way. But what I found interesting is that GNU COBOL, that's the largest compiler project, open source compiler project ever, came up with GNU COBOL, and the key to understanding that machinery is that basically GNU COBOL will translate. So before compilation, will translate your COBOL code in C. I like that very much, and it's interesting, and that's where I'm also going. Like COBOL is not out because you have that nice integration between modern day open source versions, I would say, of COBOL with C. Um, so Java, if I'm so bold to say that, well, where is Java gonna be 20 or 30 years from now? Where is Oracle gonna be 20, 30 years from now, as compared to, Microsoft and Google that have come together around GitHub? I mentioned here, I mentioned the nice integrations. Well, I didn't actually. I could talk about the nice integrations of Python, and I will actually mention one here, Jython. But you have that between Go and C and C++. That's a really nice ecosystem because from Go, you can call C and C++ routines and vice versa. And again, Go has really that advantage, like C++. It really combines a high level utilities, I would say, but you can also, force your programmers to really think about how are we going to run this thing, concurrent programming, garbage collection, all these kind of things. So these low level stuff that you don't want to look into when you're like me, but which you have to look into. So yeah, larger ecosystem is better than a smaller one, and I see the Java ecosystem becoming smaller, and I see the other ecosystems becoming larger. You may say that's going to be solved by Jython. I was initially also quite an enthusiast. What does Jython do? It's not this philosophy of we can translate one programming language into another. And vice versa. No, Jython basically is quite simple in its concept and also quite good. I think that's the best approach to do, is that you can implement Java in Python and vice versa. I put two examples here. Running Python code inside a simple Java application. This comes from, and I'm sure I didn't not always acknowledge my sources. This comes just from the Jython.org website, the official website. So again, I mean, look at Java. This is the Java program. You know that this is the public static void main. This is the entry point for a Java program. It also shows like you have public. You have what else? You have default. You have private and a fourth category. This is basically about what happens when you don't organize things using a simple concept like a namespace. Functions, variables. To what extent are they shared between the various components of your application? Static. It's the craziest. Static. Class or object is basically, there's only one instance of it. You can't construct a new one. So main, there's only one main. Okay, but then void doesn't have return function, unlike C++. You're going to do error handling quite separately, where in C++, at least, if your program returns 0, then, the program ran successfully. If it returns any other code, something went wrong. You don't have that in Java, and it's really a headache to read this main string. And this is just basically to convert the starting point of your logic. We have to define a class. Everything is a class. What is a class? Well, it's a collection of objects that share methods and properties, but it's also a file, java.class file. I don't find it intuitive. But in any case, that's not the point here. The point here is that you can import, like we do in other languages, libraries. And here we're going to import. This is the nice thing about Jython when you have installed it. You can import utilities, Python utilities. And so here this utility is very simple. One, it's the Python interpreter. From the utilities that Python has, we import the Python interpreter, and then we need to create this. Look at how many lines of codes we need and how many concepts. But But in any case, the point is here, then we created this object by interpretation, and we're going to execute a function that we created, print hello Python world. So that's execution of Python code inside a Java application. The other way around is much simpler. 2 lines, 3 lines here because we added a print line. But we import the same thing from the general Java lang package. We import very simple utility system, which comes with functions like this one. Get the property that's going to return normally the operating system, in this case the Java version, and then system also has Java time. So the Java time, it started in 1970, I think. It's a different way of keeping track of your internal clock and applications. I'm not an expert on these things, but that's as simple as it is. We write a Python program, and within that we can, thanks to Jython, very easily import all the things we are used to work with if you're an experienced Java programmer, and you can just import it and use those Java functions and methods that you're used to in Python. So that's very nice, and I think potentially I would recommend Java developers, and most of them will do that, is you're a very good Java developer, but maybe for the future, can we sort of run Python? And then it's not difficult to write Python. You can just use your same good old-fashioned Java, but we make it a Python program. And maybe I'm a bit cynical or joking, but that's a bit how I look at these things. And I think that should be it. I have a lot of other things I could talk about, good or bad experiences in architecture management, because that's what this you see 25-page notebook started a bit, a reflection on architectures, technical architectures, application architectures, and how over the past 20-30 years they have changed. But that would bring me way a lot into the weeds, and I don't want to do that. I said the objective here was to give you a bit of a feeling for what is around there as a manager and as a CIO for sure, but I'm sure CIOs know more about these things than I do. At least some of them pretend that. So that's it. That's all, folks. You don't need to like my videos. I said they're more like for me to have something handy when I'm indeed asked to, chat or give advice about how we should do stuff in this brave new world of information technology. So thanks a lot, and I wish you a very, very